9 is it? Session 9. Okay, so guys, let's begin with our today's lecture. So we are going to start with a new concept that is called as this keyword. See, constructors concept is not yet over. Okay, constructor concept we are again going to have a look at it, but we are going to learn constructor with a concept of this keyword. So we'll explore what is this keyword, okay, and how it can be beneficial for us. Observe here now. So firstly, when you create an object a1 is equal to new a. See, when an object is created, guys, we know that a1 here will hold the address of that object. Correct? Everybody now they're aware of it that a1 will hold the address of this object. But at the same time now, a special keyword in Java called as this will get created automatically. And the first purpose of this keyword is it will also store the object's address, which means the same object's address will be stored in two places. Will be stored in what? Two places. One, it will be stored inside this keyword, and two, the same address will be stored in A1. So this keyword first purpose would be to store your object's address. See this here with an example that will give you more clarity. So let me close all these tabs, and then after we'll go here, open this a.java, and in this let's create a constructor. Even if you don't create, default constructor will come into picture, but still I'm simply keeping it. So while debugging, things will become easier for you guys. Okay, so now I'll create here an object a1 is equal to new a. So if you carefully observe here, when I run this application in debug mode, you will see that in your variable section, variables, there is nothing present here. Okay, now moment I do step into, from line 14 it is calling a constructor. Moment it called, one this keyword got created. Can you see that? And when I click on this keyword, it is holding some object's address. When I click on this keyword got generated. Moment I shifted from here to here, moment constructor is called, one empty object is created. And that object which is created is empty, but that object's address is there because it is created. It might be an empty object, but object is still created. No, it's a partial object without any content, but object is created. Object's address is automatically getting stored in this keyword. I did not even create that. I'll show you once again. Observe. I'm clicking on debug. Just go to the variable section. Click on this tab. Now see, I'm at line 14. You know, object creation will happen only when constructor is called. Constructor is as of now not called. Do step into. Moment it calls a constructor, this keyword got created. When I click on that, I can see the object's address inside it. Correct? Now let's do a step over. Step over. Closing bracket of the constructor will go back to line 14. Correct? And now when you move further, look at that A1 is giving me the same address. Yes or no? Is the address same or not? Now we'll see this more clearly. Hold on. So what did you observe here? Moment object is created, this keyword is getting created, object's address is getting stored in it, and inside this variable A1 also, object's address is getting stored. Now what I'll do is, I'll go here, build one method, public void and test. Let's try to print inside this keyword. And since it is a non-static method, call that with object's address. Now carefully observe. Carefully observe here. Okay. So I'm going to start the debugging. Stops at line 13. Now let's go to the variable section. Now what I'll do is I will do step into. Now when I do step into, what got created? Step over, step over, step over. Now you observe in variable A1, some address has got stored. Some address has got stored in A1. Can you see that address? Now I'll go to test method by doing step into. And now when you see here also the same address is stored. You can see that in the console as well. Here. Now when I print this, it is printing the address. It is the same address that I could see here. Can you see that? The same address that was present here, you can see that. Now if you want to see this more clearly, let's print here SYSO A1. So what this prints, is it same? Let's observe. Okay. Let's debug. Observe now. I'll just do step over. Okay, when I do step over, object got created. Step over. What did it print? This address is printed by line 14. Now let's go to step into. Now line 18 is printing an address. Are they same? Are they same or different? They're same. So what is happening here? When an object is created, that object's address is automatically stored in this keyword. Correct? This object when I created, this object's address is stored in A1 and this keyword, two places. Observe here. That is why when you go to the console, A1 and this keyword, they are printing same object's address, which means when you're creating object's address is present in how many places? One, it is present in A1 and then it is present in, now closing bracket of test, so go back, closing bracket of main, program stops. Let's see this here again. People, now see, stopping at line 13, step over. What did A1 print? Address. Now this keyword, is it printing same address of A1? Step into, step over. Which means what do you analyze by this is, when an object is created, its address is present in this keyword as well as the reference variable A1 that you created. Let's click on resume to execute complete program and stop. Okay. So the first point is, this keyword acts like a special reference variable that holds object's address. Can I tell this? This keyword acts like a special reference variable that holds object's address. Okay. Now let's continue further. Observe. Now let's say this object has one variable int x is equal to 10. Now since A1 has object's address, I can write A1 to locate the object dot enter the object and give me variable x. Same way, if you want to access this variable x, I can also write this keyword because that also has object's address. dot enter that object and give me variable x. How many ways I can access now non-static member? How many ways? Two ways. Observe here. Now I'm going to create here one variable. Int x is equal to 10. Default constructor will be applicable here. Don't worry about that. Okay, don't worry about that. Is this clear? Don't worry about this package and all. We'll see later. Now observe. I'll debug. Line number 7. Step over. Hold on. We will now access that variable a1.x, this.x. This and this are printing the content of the same variable x present inside the object. So now when I debug, okay, you do step over, see here a1. This is the object's address. Using that object's address, I'm accessing variable, which means this variable x belongs to this object. Step into. Now see, step over, come here. This is also holding the same object's address. The same object variable x is there, I'm accessing it. Step over, see the console. Did you understand this part? Online students, offline students, are you all clear with this part? Please do let me know. Did you understand the first thing that I talked about? Yes. So this keyword is automatically getting created when object is created. See here, when I'm now running this, can you observe in our variables section, when I now step over, right, internally this keyword is automatically created. Okay, are you understanding internally what is created? Now if you want to see that how these keywords are created, then you make a call to the constructor. Do what? Step into. Now when you do step into, you see here this keyword. So even before a1 is initialized, this keyword is getting created. Did you understand that now? When you go to that object and do step into, that's how you can see here this variable, this and that can access x. X is present inside the object whose address is present in this. Now when you do step over, right, you see that what happened to that value. So as of now I can access that object using this.x. But when you go back further, now see a1 created. So same variable I can access now using a1. Two ways object content is accessible in Java using a1 or this keyword. Now let's continue further. Everybody got this point? If anybody has any doubts, you can communicate with me. Now why we use this keyword, this all you will get to know. We will all discuss this. What if 2 objects are created, 3 are created, hundreds are created? That is what we are going to discuss further. Okay. Now the next thing is, using this keyword, you can also call a method. Now observe the flow here. I'm going to write here this dot test2. Let's build here another method, public void test2, and this will print from test2. Let's put a breakpoint here. Delete this line, no longer required. Now I'm going to click on the debug icon. Which line is it stopping at? How to move from 7 to 8? Step over. Now how do I go to this method? Step into. So using a1 I'm calling test. So now this keyword has a1 address. Okay, this keyword has what? A1 address. If you just go here, the variable section, now observe it's the same address it is having what a1 has got. What a1 has got. Are you understanding? Same address what a1 has got. So now from here I will again to step into. Using this keyword, what am I calling? Test2. So test2 I'm calling using this keyword. From line 11 I'm calling this. Now closing bracket. Which line will it go to? Which line it was called from? It was called from 11. You are at line 15 closing bracket. Called from 11. So it will go back to which line? 11 and stops at 12. Now line 12 was called from where? 8. So this will go back to 8, stop at 9. 9 is a closing bracket of main. program stops. See the output. Did you all get this program? Please tell me. Did you all get this program, guys? Everyone, tell me what is the first thing this keyword does? Stores object's address and it is automatically created. What is the second thing this keyword does? Can access object content. What is object content? Non-static members, variables and methods. I can do that. Now let's proceed further. Whenever you're using this keyword, you have to be a bit careful. Do you see any error right now? Do you see any error right now? Do you see any error right now? Check here. Any error? No. But moment I make the method static, what do you see? You cannot use this keyword inside a static method. Okay, what is the limitation of this keyword? You cannot use this keyword inside a static method. What is main? Can I use this keyword inside main? Why? Because main method is. Now I cannot use this keyword inside main. I cannot use this keyword inside main because main is a static method. Remove the static word. Do you see the error is gone? Put static back. Error. Remove static. Error is gone. Put static back. There's an error. So what do you understand by this? You cannot use this keyword inside a static method. Is this clear, everyone? Let's proceed further now. Now, I have some more things to discuss here now. No, it will not cause confusion. This is, you understand the concept, then you'll understand how it can be beneficial for us. See, the first benefit is, observe, okay, Raja, observe. Now, I'm creating this variable A1. I'm creating variable A1 inside main. So, is it a local variable? Is it static or non-static? Huh? Non-static. Where is it created? Any variable created inside a main method are local variables, right? So can I use this variable A1 outside main? Huh? What will happen if I use it? Am I getting error? Can you see the error? Why error? Can you tell me why error? Because A1 is local to main. Means A1 can be used within main. You can use A1 within main. Outside main it will not work. But what if I want to access the content of this object outside main? That's where this keyword becomes beneficial. See now, I am writing int x. What is the default value? 0. Now this variable x is in this object. To access this x, I cannot use a1 here because a1 is local. But I can still use this keyword and access. Did you understand? Now still it will print the content of that variable, which is 0. Did you get this now? Yes. Yes. Did you understand this? Everyone? So there are a lot of benefits. We have just talked about one so far, but let's continue further now. So now we'll quickly read the notes once. Okay, I'll just go to this keyword and then we'll continue our discussion further. So let me press Control F, type here this keyword. Now read the very first line loudly. This keyword is a special reference variable that holds object's address. Can you please look at this program and tell me, will A1 and this keyword address be same or it will be different address? So is it printing same address? Yes. Second, using this keyword, we can access non-static members of the class. So X is a non-static member. I'm able to access X using A1 and this keyword. Is this program clear? Yes. Look at the next thing now. The next thing. I'm calling test method using this keyword. Will it work? You're calling a1.test1, then you're calling this dot test2. Will it print 100? I'm able to call test2 method using this keyword because it is non-static method and that belongs to the object. Are you understanding? Okay. Did you understand this example? Do you want me to repeat this again? No. Everyone clear? Okay. Next. We cannot use this keyword inside static method. This is a static method. If I'm using this keyword, what are we getting? Error because cannot be used inside. Now here again, error because we cannot use this keyword inside static method. Now see here, what are we doing? We are creating an object. How many variables are loaded in that? X and Y. So I'm accessing X and Y using this keyword. It has to work. Did you all understand these examples now? Everyone? Okay. Now this line is very, very important. Okay. So stay focused and listen to me carefully now. Let's assume I have here A1 is equal to new A. Now I'm going to write here A1 dot test, which means I'm calling some method. I'll create A2 is equal to new A, and we'll write here A2 dot test, and then I'll write down A1 dot test. Again A3 is equal to new A, and we'll write here A3 dot test, and then I'm going to write A1 dot test. How many objects are there? 3 objects are there. So let's put that here. You said 3 objects are there. 1, 2, and 3. Now listen very carefully. You have only one this keyword throughout the program. It's not that there are 3 objects and you have 3 different this keyword. Throughout this program, guys, there will be only one this keyword. There will be only one this keyword. Now how does this work is, when this line of code is running, it is object A1 created. Since the object A1 is created, this keyword will hold the address of A1. Now when you come at this line, still object A1 is running. Okay, I'm using object A1 only. Because still object A1 is running at line 2, this keyword will still hold same object's address. But when you now come to this line, it is now creating a new object. Now since the current object running is now A2, this keyword will automatically change its address from A1 to A2, which means this keyword is internally changing its address to that current object which is running. Which is the current object running? A2. When you come at this line, which is the current object running? Which means this keyword will still hold address of A2. But when you come at this line, which is the object running? So now what this keyword will do? It will change its address from A2 to A1. Now come to this line. Now when you come to this line, A3 means a new object is created. Current object running is A3. So this keyword will now change its address from A2 to what? A3. Now when you come to this line, still it is A3. So it will continue to hold address of A3. Now when you come to this line, since current object running is A1, this keyword will change its address and again store A1's address. See, in a very simple way, I can demonstrate this in 2 ways to you. Okay, I'll just create here a constructor. Every time object is created, constructor is called. Do you agree with that? A1 is equal to new A. Then A2 is equal to new A. Let's write A3 is equal to new A. See the first example. I'll put a breakpoint here and carefully observe here in the variables section. Okay. Now I'm going to run this in debug mode. Which is the first object getting created? A1. When it will be created? When the constructor is called. So do step into this keyword, take this object's address, save it on the notepad. Save it on what? Notepad. This is the first object's address I got. Correct? Now, execute that constructor, come back, store the value in A1, go to A2. Now this time, which is the object getting created? So when you do step into, same this keyword, you see what was the earlier address, and now what is the address? Is it same or different? Which means the address in that this keyword got changed because the current object running is now A2. Now when you go to A3, which is the current object running? A3. So now when you notice, again this keyword address has got changed. Yes, the same this keyword object's address is automatically changing, and now when you go back, A3 initialized program stopped. We can do this in a more better way by writing here one SOP. This is A1, this is A2, and this one is A3. Keep this in mind, A3. Now I will call a test method, public void and test method. You can also see here when I'm writing this keyword, when you now write a1.test, this keyword should print address of A1 because the current object running at line 15 is A1. Now when I write a2.test, when line 16 runs, this keyword should print the address of A2, which is this address. And when I now print a3 dot test, then it should print the address of A3. Again, when I print a1.test, this keyword will print address of. So let's put a breakpoint here. Okay, so that it will stop here, and that's what we need to analyze now. Line 15. Line 15. You can see here in the console, already addresses are printed. This is A1, A2, A3. Now, step into, step over. What is the address it's printing? What is the address it's printing? The address that it is printing, the address that it is printing is now basically A1. Are you understanding? The address that it is printing is what? A1. You go back. Now we are at A2. Step into. So you're debugging. What is it showing now? This address printed, is it of A2? Yes. Is it changing the address? Now go back. Now step into. Now see, this address printed is A3. Go back. Again step into. Okay, step over. Now see, is it printing the same address that is of A1? Is this keyword address changing depending on which current object is running? Do you agree with this point, all of you? Yes, everybody got this point? Yes, do you want to practice this much? Huh? What do you want to do? Tell me. Do you want to practice this much? But before that, let's go through the notes. Observe. This keyword holds current address, okay, current object's address that is executing. So when you call a2.test, it will print address of A2. a1.test, it will print address of A1. Okay. For now, just handwritten notes and analyze the flow of the program on sheet of paper. Soon we are going to install the IDE. Then you will practice the program by debugging. Any program that you practice should be debugging. So you should call me by. I would not call you. You have to call me. See, I will forget. Correct? But there was no call. No, I will forget. See, Mintu, I will not remember. I just gave the timing that I will not be in class that time. I would have forgotten by then. Okay? Now, because I don't even have your number in my personal mobile phone. Now, anyways, let's continue. Further in my next class, we will look at this keyword to call a constructor. Is this part clear, all of you? Do you want me to stop here? Do you want to practice this much? Please tell me. Yes, everyone. Is today's class 100% clear? Right? Good to go for practicing. Recorded class you have to see once again, and then prepare the notes. Only when you prepare notes you'll be thorough. And one who has missed my initial class, they cannot understand today's class. Reason being, all my previous lectures, who has completed it, only his understanding will be 100% in tomorrow's class again, because they're all interlinked. See, I've covered constructors earlier, I've talked about objects earlier, debugging earlier. Somebody has come to class directly today, he does not know debugging at all, which I mentioned earlier, so he will be struggling to follow me. Okay, so ensure that people do this. I want to practice as 10 times to 50 times at the same syntax. That's good. If you have that patience, do that. You should do that actually. Only when you keep doing the same thing several times, you get perfect with it. And that's true. See, if you look at my case, I have been taking classes from the last 18 years. So, obviously, 18 years is a big time. When you keep taking classes for the last 18 years, I don't require any book to take the class. Correct? So what is it telling? I'm just relating to basically the reality. When you practice the same thing 10 times, actually you're getting more seasoned with the concept and syntaxes. Okay, and that's the best way to practice. See you, Baba, tomorrow. Tomorrow I'll take the classes. Friday it is. Same time. This keyword will continue. Okay, bye.